There is no horizon, only a muted gradient of darkness where the sea and sky dissolve into each other, indistinguishable. The aircraft moves through it without reference. No visible coastline, no ground lights, no stars strong enough to define position. Outside the cockpit windows, the world has been reduced to absence. Inside, the instruments carry the burden of reality. A steady hum fills the cockpit. Turboprop engines maintain a consistent rhythm, their vibration absorbed into the structure. The aircraft is stable. Airspeed holds. Altitude trends downward, but gradually, deliberately. Nothing suggests urgency. Nothing suggests failure. Only a quiet descent through invisible air. The altimeter unwinds in measured increments, a needle rotating across numbers that represent distance from terrain that cannot be seen. The vertical speed indicator holds a controlled rate. The descent profile appears normal, procedural. There is no abrupt movement, no aggressive correction. But outside, conditions are not neutral. The air is dense with coastal haze, an indistinct layer that absorbs light rather than reflecting it. It flattens depth perception. It removes contrast. Even if the ground were near, it would not yet be visible. The aircraft continues forward. Navigation at this stage depends entirely on abstraction. Radio signals, bearings, timings, a system of invisible lines drawn across terrain and water, guiding the aircraft toward a destination that remains hidden behind weather and darkness. There is no visual confirmation, only trust, a slight adjustment in heading, subtle, barely perceptible. The aircraft banks gently, correcting course along an inbound track defined not by sight, but by instrumentation. The correction is smooth, controlled, routine, then level again. The descent continues. Altitude decreases through a threshold where terrain awareness begins to matter more than navigation precision. In daylight, this would be the point where coastline features emerge, shapes forming from shadow. At night, with clear conditions, scattered lights might define elevation changes. But tonight, there is nothing. The cockpit lighting remains dim, preserving night vision that has no external reference to attach to. Reflections shimmer faintly against the windshield, instrument glow mirrored against blackness. The aircraft is alone in its environment. A tone breaks the silence briefly. A routine call. Not urgent, not unexpected. It passes, acknowledged, and disappears as quickly as it came. The frequency returns to stillness. The descent rate remains constant. Every system indicates normal operation. Engine parameters steady. No warnings. No anomalies. The aircraft behaves exactly as designed. Yet the environment continues to conceal. Altitude unwinds further. The margin between aircraft and terrain narrows. Not abruptly, but continuously, each second reducing separation by small, precise increments. There is no sudden drop, no dramatic shift, only time passing. Another minor correction. The aircraft aligns more precisely with its intended track. The movement is almost imperceptible to anyone not watching closely. A slight bank, a gentle return. Everything remains controlled, but control, in this moment, depends entirely on interpretation. The instruments provide data, numbers, needles, signals, but they do not show terrain. They do not show rising ground ahead. They do not reveal the shape of the landscape concealed beneath cloud and darkness. They require context. And context, here, is incomplete. The descent continues into a layer where visibility is no longer just limited. It is effectively absent. Even the faint suggestion of horizon has disappeared. The windshield reflects only the interior of the cockpit now. Beyond it, there is nothing to anchor perception. The aircraft presses forward. Seconds pass, then more, each one uneventful, each one indistinguishable from the last. The engines maintain their tone. The air remained smooth. No turbulence. No instability. Only the gradual approach toward a surface that cannot yet be seen. The altimeter continues its steady rotation. Lower and lower. At this stage, the difference between safety and danger is no longer defined by mechanical performance. The aircraft is functioning correctly. It responds precisely. It obeys every input. The difference is defined by awareness, where the aircraft is, where it is expected to be, and where the terrain actually rises. Those 3 points remain separate, invisible to each other. A final segment of descent approaches, one that, under normal conditions, would transition from instrument reliance to visual confirmation. A runway environment, approach lights, some indication that the aircraft's path is correct. But there is still nothing. No lights, no outline, no confirmation. Only instruments, only interpretation. The aircraft continues descending, calmly, precisely, unaware of what lies ahead. Seaview Air was a small regional airline operating along the rugged coastline of its home country. Founded in the late 1970s, it served isolated communities, linking small towns with larger urban centers. Its fleet was modest, twin-engine turboprops, optimized for short-haul routes and short runways. Reliability and familiarity were the airline's strengths, though infrastructure limitations meant flights often occurred in marginal conditions. The route that would become fatal in 1994 was routine, flown multiple times each week. It connected a coastal town perched on cliffs to a regional hub several hundred kilometers inland. The flight itself was short, less than an hour, but the final approach required careful navigation. The runway was situated on a plateau near the sea, surrounded by undulating terrain that offered little margin for error, particularly under low visibility conditions. In 1994, regional aviation was still adapting to technological improvements that were becoming standard in larger carriers. Seaview Air's aircraft were equipped with basic navigation aids, VOR, NDB, and local airport beacons. Ground proximity warning systems were present only on newer models, and not every aircraft in the fleet carried them. True terrain awareness relied heavily on charts, radio navigation, and pilot experience. Weather was a constant consideration. Coastal fog rolled in unpredictably, and sudden shifts in wind and visibility could occur within minutes. Pilots relied on visual references when possible, but often instruments were the only guide. At night, haze over the water flattened depth perception, and the horizon could disappear entirely, creating an environment in which even minor deviations could have serious consequences. Seaview Air's crew culture emphasized routine and efficiency. Flights were often conducted with tight schedules, and pilots were expected to manage workload with minimal external support. Training covered standard procedures and emergency protocols, but limitations existed in simulating the combination of low visibility, coastal terrain, and approach complexity. Pilots were skilled and experienced, but the margin for error remained slim. This was a flight that would test both human and mechanical systems. The aircraft, reliable and proven, carried crews accustomed to the route, yet the environment was dynamic and unforgiving. Navigation required precision. Timing had to be exact. Awareness had to be constant. In essence, the stage was set not by dramatic failures, but by the invisible alignment of factors: a routine route, variable weather, demanding terrain, and technological limits. The context was unremarkable at first glance, yet it contained all the seeds of risk that would later converge in a single, irreversible moment. The aircraft was a twin-engine turboprop, a workhorse of regional aviation. Its systems were reliable, proven over thousands of hours, but not infallible. The engines provided steady thrust, propellers generating lift with predictable efficiency. Fuel systems, hydraulics, and flight controls were conventional, without redundancy beyond the standard design. Instrumentation reflected the technology of the early 1990s: analog gauges, basic autopilot, and radio navigation aids. Ground proximity warning systems were limited, with no advanced terrain mapping. Safety depended on pilot interpretation, discipline, and vigilance. The crew consisted of a captain and first officer, both experienced in regional operations. The captain had flown similar aircraft for years, intimately familiar with the route and the aircraft's quirks. The first officer was competent, trained to operate under instrument conditions, but less seasoned on this particular approach. Both were professional, conscientious, and accustomed to marginal weather. Fatigue was minimal, yet the cumulative pressure of schedule adherence and environmental complexity created an invisible burden. The environment amplified every decision. Coastal haze reduced visual cues. Moonless skies eliminated horizon reference. Terrain was deceptive. Cliffs fell sharply to the water, valleys hit obstacles, and the runway appeared as a flat target but required precise alignment from the air. Weather could change without warning. Fog could thicken in minutes, and wind gusts could shift subtly, affecting airspeed and descent path. Navigation systems provided guidance, yet their limits were critical. VOR signals were reliable, but resolution was coarse. NDB approaches demanded exact tuning and interpretation. Local beacons indicated runway location, but offered no altitude profile. Autopilot could maintain heading and altitude, but could not correct for human misjudgment or invisible terrain. Instruments were the only connection to reality in a night without reference, yet they presented data without context. The pilots needed to translate numbers into safe action. The combination of aircraft, crew, environment, and systems formed a delicate balance. Each element alone was manageable. Each had a margin of safety. But together, in this isolated coastal approach at night, the margin narrowed. Tiny deviations, slight heading changes, subtle misreading of altitudes, underestimation of descent rates could accumulate. The environment offered no feedback. Systems offered no warning. Awareness became the only safeguard, and it was dependent entirely on human interpretation. In this configuration, risk was invisible. Procedures were followed. Instruments functioned. The aircraft behaved as designed. Yet the alignment of factors, coastal terrain, limited navigation, dim light, and environmental unpredictability, created a scenario in which the line between safe approach and accident was thinner than it appeared. The stage was now fully set. A reliable aircraft, competent crew, invisible hazards, and systems that demanded careful human oversight. Everything functioned, but nothing could substitute for the clarity of visual reference lost to night and fog. The final approach began like any other, methodical, controlled. The aircraft descended along the published procedure, its instruments providing the only guidance through the dense coastal haze. The crew followed the checklist, monitored airspeed, and maintained alignment with the inbound track. Everything appeared normal, textbook even, but the margin for error was narrow. Altitude unwound steadily. The coastline below remained invisible. Depth perception offered no reference. Small, almost imperceptible deviations began to accumulate. A slightly shallow turn, a minor misread of the vertical speed, an underestimation of the wind component. None alone would have mattered. Together, they began to erode the safety buffer. The autopilot held heading and altitude, but subtle corrections required human oversight. The captain scanned instruments, comparing readings to charted approach parameters. The first officer called out headings, altitudes, and distance markers, each precise, each accurate. Yet the environment demanded interpretation as much as observation, and interpretation falters without visual anchors. Minutes stretched in controlled tension. The descent continued at a uniform rate. The air was smooth, the engine steady, the aircraft obedient. But the terrain was rising invisibly, cliffs hidden by night and haze, valleys masked in shadow. The intended glide path was intersecting with a slope that had not been factored into real-time decision-making. A subtle alert flickered, a minor radio call, a muted instrument warning, but it passed without interruption of routine. No abrupt warnings sounded, no dramatic alarms, only a quiet misalignment of position relative to unseen terrain. The margin shrank with each second. Then, in a moment measured by physics, not drama, the aircraft entered the final segment where the procedural descent intersected rising terrain. Pilots had no visual confirmation. Instruments were still nominal. Systems were operational. Yet the invisible environment had moved closer than any charted number could account for. In those last seconds, situational awareness failed to match reality. Decisions made were sound based on available data, but the data itself was incomplete. The aircraft struck the first obstacle, not violently, but with irreversible consequence. The sequence unfolded in a chain of precise, inevitable actions: altitude, trajectory, terrain, speed, all aligned in a way that no human or mechanical intervention could reverse once the initial contact occurred. Silence returned. Outside, the night reclaimed its void. Inside, instruments were frozen in a final reading. The systems remained functional. The engines, if still running, produced no corrective outcome. The aircraft, designed for safety and reliability, had met an environment it could not perceive. The accident was not sudden in sensation. It was gradual in consequence. Each prior decision, each procedural step, had contributed to the final alignment. The outcome was a product of convergence. Human, technical, and environmental factors perfectly intertwined. The response began quietly. Emergency services reached the site as quickly as conditions allowed, but the location was remote. Cliffs, dense fog, and limited access complicated recovery. Crews navigated with caution, not in haste, understanding that safety and preservation of evidence were paramount. The wreckage was examined without dramatization. Investigators focused on facts, measurements, and timelines. The flight data recorder and cockpit voice recorder, when recovered, provided insight into the final minutes. Instrument readings confirmed a steady, controlled descent. Audio indicated routine communications, standard callouts, and adherence to procedures. There was no panic, no mechanical failure audible, only a gradual misalignment with unseen terrain. Analysis revealed a subtle sequence of deviations: heading drift, descent rate, minor miscalculations amplified by the absence of visual references. Investigators reconstructed the approach profile against topographic data. Coastal cliffs rose more steeply than expected in the path of the final segment. Haze and darkness had masked early visual cues. The investigation highlighted limitations of available navigation aids and the absence of advanced terrain warning systems. These factors combined to create a scenario in which even experienced pilots could inadvertently intersect terrain. The official findings concluded that the accident was a controlled flight into terrain. Probable cause was identified as a loss of situational awareness during the final approach, compounded by limited navigational aids and environmental obscuration. Contributing factors included marginal weather, low visibility, and the inherent demands of the coastal approach. Regulatory authorities and the airline responded with measured reforms. Navigation procedures were updated to account for high-risk terrain. Training programs incorporated scenario-based simulations for low-visibility approaches over coastal regions. Fleet upgrades prioritized enhanced terrain awareness technology. The accident prompted broader discussion across the industry about operational safety in remote, instrument-reliant environments. The human and organizational impact was profound, though measured. Lessons extended beyond immediate procedures to encompass culture, training, and risk recognition. The loss underscored that in aviation, routine flights carry latent risks, and that small, invisible deviations can accumulate into catastrophic outcomes. The Seaview Air crash became a case study, not for dramatic spectacle, but for meticulous reconstruction, methodical analysis, and the sober recognition of limits within human, mechanical, and environmental systems. The Seaview Air crash left no single lesson, no simple cautionary tale. Its legacy is measured not in spectacle, but in the quiet, methodical improvements it inspired across aviation. Procedures evolved, training intensified, and technology advanced. Each reform a direct response to the vulnerabilities exposed that night. Terrain awareness and warning systems, TAWS, became more widely implemented in regional aircraft. Flight crews were trained to recognize and compensate for environments that offered little visual guidance. Approach protocols were updated to include stricter altitude checks and cross-verification, particularly in coastal and mountainous regions. The accident also reinforced the importance of conservative decision-making when environmental cues are obscured. Margins must be respected even in routine operations. For pilots, the lessons were subtle but profound. Awareness, discipline, and precise interpretation of instruments became more than procedural expectations. They became safeguards against the invisible hazards of night, fog, and unchatted perception. The human factor was never isolated, never blamed. It was understood as part of a chain of interdependent elements that must be managed, always with respect for limits. The airline itself adopted new standards, improving navigation aids, updating charts, and emphasizing scenario-based training. Across the industry, regulators recognize that regional operators, often flying in demanding environments, required the same rigor and technological support as major carriers. Standards shifted quietly, deliberately, shaped by analysis rather than anecdote. And finally, there's reflection in stillness. The aircraft, the crew, the flight path, and the environment all converge in precise moment that could not be reversed. Yet from that convergence emerged a measured and enduring safety culture. The story ends not in dramatic closure, but in the ongoing application of lessons learned, vigilance in procedure, respect for limitations, and a deliberate pursuit of safety. The Seaview Air crash is remembered not for the final descent alone, but for what followed, a quiet strengthening of the chain that binds human, machine, and environment together. Its legacy is invisible in the air, unremarkable in daily operations, yet present in every flight where procedure and awareness prevent the unseen from becoming the inevitable.